Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif bin Ramlan. Okay, I'm going to tell you or to show you about our case study referring to our subject, the reactor technology. We've been doing study about the anaerobic reactor. Okay, first of all, let me clarify to you the meaning of the term anaerobic. As we know the aerobic and anaerobic. Aerobic is a presence of oxygen and anaerobic is the absence of the oxygen. Okay. Secondly is reactor. Reactor is an apparatus or instrument that is used to react something or to do a reaction between the subreactants. Okay, now this is the time that we will explain to you about the anaerobic reactor. This anaerobic reactor we will explain through this our beautiful slide that is covered by our members.
Process description. Anaerobic buffer reactors, which would include the bioterminator digester, have been applied to industrial waste in limited applications over the past 20 years. Consists of 5 separate chambers, each of which plays a specialized role in the progression of anaerobic digestion of feed solids, from initial hydrolysis to ultimately generation of methane. The digester operates at mesophilic temperatures, approximately 35 degrees Celsius. The first chamber is largely populated with hydrolyzing and acid-forming microorganisms that solubilize the feed organic solids, leading to the formation of volatile fatty acids, VFAs, and other intermediate products. The influent organic solids will settle in the first chamber where hydrolysis occurs. The waste products generated by the hydrolyzing and acidifying bacteria are VFAs, a liquid, carbon dioxide, and hydrogen. As a liquid, the VFAs migrate downstream to the subsequent chambers where they become the food source for organisms responsible for fermentation and other reactions, ultimately resulting in the formation of methane. As in the case with any anaerobic digester, most of the feed solids entering the bioterminator disappear in this first intense digestion step. Subsequent steps of the digestion process produce new solids biomass that feed on the previously generated dissolved organics and other reaction products. In the subsequent reaction chambers, percentage of estrogenic and methanogenic bacteria increases. In subsequent chambers of the bioterminator, a biomass slush blanket forms to produce specialized series of microbial colonies. Subsequent treatment of the digester effluent will be required if phosphorus and ammonia must be removed from the process. Methane gas rises to the top of the digester and can be collected as produce. In the bioterminator, the acidifiers remain behind in the first chamber and form a slush blanket. The biomass remains in each chamber while the liquid slowly migrates through the reactor. Feed solids will accumulate in the chambers and or exit the reactor with the effluent in a dissolved state. Feed solids consist of sodium, potassium, chloride, sulfate, silica, calcium, and magnesium. Periodically, a small portion of the solids blanket in each chamber is wasted from the bottom of the reactor to a container filter. This removes settled grit and enough accumulated inert material to keep the process in balance. Meanwhile, in the container filter, the wasted solids are allowed to drain by gravity and the contents are disposed in a landfill. This is the PFD diagram.